right, pre-algebra 13.6, surface area of pyramids, cones, and spheres today. Two key differences between prisms and pyramids. Probably already know this. Pyramids have only one base instead of two, and the faces that make up the lateral surface are triangular instead of rectangular. So, definition of a pyramid is a 3D figure with a single polygonal base and triangular lateral faces that meet at a common point known as the vertex of the pyramid. The length of the altitude of the pyramid, capital H, is the perpendicular distance from the vertex to the base. So in this diagram right here, it's this dashed line dropped here. We know it's perpendicular because we have a right angle down to the base, okay? Each triangular face has its own altitude, but with respect to the pyramid, it is known as the slant height. So what that means is, think about a pyramid. All the faces are slanted, right? So that they can all meet at that vertex. And so each one of the faces has its own height, that slanted height, and that is the slant height, and it is delineated with a lowercase l. The base of a pyramid can be any polygon. The most common bases are triangles and squares. The lateral surface area, capital L or big L, of a pyramid is the sum. So lateral surface area, big L, of a pyramid is the sum of the triangular faces. The surface area, capital S or big S, of a pyramid is the sum of all of the areas of the faces, including the base. So very similar to what we worked through yesterday. To find the surface area, find the areas of all the faces and then add them together. A regular pyramid has a regular polygon as its base, and its vertex is directly above the center of the base. Pyramids with squares or equilateral triangles for bases are examples of regular pyramids. The pyramid below has a square base. Here is our square base, and 4 faces that are congruent triangles. Notice that the heights lowercase h of the triangles are not the height capital H of the pyramid, but they are rather the slant heights, lowercase l, of the lateral faces. So what that means is this dashed line here that says 10 feet, that is the lowercase h. That is the height of each one of these triangles, which in a pyramid would be synonymous with lowercase l, the slant height, okay? So first, we're going to find the area of the base. We are told it's a square, all right, square base. So we know that the formula is going to be side squared. The side is 6 feet, so the area of the base is 36 feet squared. The area of one of the triangular faces is the area of a triangle, 1/2 base times height, okay, where height is replaced here with lowercase l because that is synonymous with the height of each one of these triangles, the slant height, all right? So 1/2 times the base, each one of these triangles has a base of 6 and a slant height of 10. 1/2 times 6 times 10 is 30 feet squared. How many triangular faces do we have? Well, if we have a square base, we have 4 triangular faces. So the total surface area of this pyramid is going to be 36. That's the area of the base, plus 4 times 30, because 30 is the area of each one of the triangles, and we have 4 of those triangles, all right? So the total surface area, the big S, of this pyramid would be 156 feet squared. A specific formula for the lateral surface area of a regular pyramid can be developed since all slant heights are the same. In the net below, the height of the row of triangles is the slant height of the triangular faces, and the length of the row of triangles is the perimeter of the base. So we've got this net kind of drawn out here. A parallelogram can be made by inverting the row of triangles, that means turning it upside down, and combining the result with the original row of triangles. That's what's happening here. The area of this parallelogram would be the perimeter of the pyramid's base, lowercase p, times the slant height, lowercase l. Therefore, the lateral surface area, capital L, big L, would be half the area of the parallelogram. So big L is 1/2 times lowercase p, the perimeter of the pyramid's base, times the slant height. Total surface area, capital S, can be determined by adding the lateral surface area, big L, and the area of the base, big B, just like what we were working with yesterday. So we have formula, lateral surface area of a regular pyramid. Okay, lateral surface area is equal to 1/2 times the perimeter of the pyramid's base, okay, perimeter of the base, and the slant height of the lateral faces. And then we have the formula for the surface area of a regular pyramid. Big S is equal to big L plus big B, which is the lateral surface area plus the area of the base. Okay, example number 1. Find the lateral surface area and the surface area of the square pyramid, right? So we have a square pyramid, which means we have a square as the base. And how many faces are we going to have? We're going to have 4. Okay, we're going to have 4 faces because there is a square base. First thing we're going to do is find the lateral surface area. Lateral surface area, big L, is equal to 1/2 times the perimeter times the slant height. Okay, here is the slant height, is the height of each one of those triangular faces. So it is 13. And what is the perimeter of the base? Well, it's a square base. Each one of the sides is 10 meters. So the perimeter of the base is 4 times 10, right? 10 plus 10 plus 10 plus 10. 4 times 10 is 40, okay? So now we just plug in what we have. Lowercase l slant height times 40. So 13 times 40 times 1/2 gives us 260 meters squared, okay? Then we have the area of the base, okay? What's the area of the base? It's just the area of a square. 10 squared is 100 meters squared. So the total surface area, big S, is big L plus big B. 260 plus 100 is equal to 360 meters squared. The altitude of a pyramid, big H, the slant height, little l, and the perpendicular distance from the center of the base to a side of the base form a right triangle. And in this, I'm just going to do it in example number 1. We can see that here. So this would be the big H. Okay, and we can see we're creating a right triangle here along with that slant height. Okay, if you know 2 of these quantities, you can apply the Pythagorean theorem to find the third. Okay, so take a look at the pyramid that we have in example number 2. Notice we have this height right here. So this is big H. Okay, this is big H. This is the height of the pyramid. All right. And we have this half. Okay, this is half of the length of the base. All right, so it's 10 right there. All right. Then we have the slant height here, lowercase l, we don't know. So I'm just going to draw this right triangle out here so we can see what's happening. Okay, so here's our big H, which is 24. Here is half of the length of that base. So that base is 20, so half of it, okay, because we're from the center of the base to the side, is 10. And then our hypotenuse here is the slant height, L, which is what we don't know. So we're just going to plug everything into the Pythagorean theorem. L squared is equal to a squared plus h squared. So they're calling 10a. All right. So L squared is equal to 10 squared plus 24 squared, 100 plus 576. Okay. So L squared is equal to 676. Take the square root of both sides, okay? And L is equal to 26 units. All right. Skill check number 1 says find the lateral surface area and total surface area of the following pyramids. Drawing a net may be helpful. All right. So number 1, square pyramid with base side length is 12 centimeters, slant height is 8 centimeters. So lateral surface area, actually let me change colors so we don't get confused with what I did up above. All right, so lateral surface area, 1/2 P times L. All right, so what's the perimeter of a square pyramid with base of 12 centimeters for each side? Okay, the perimeter is going to be 4 times 12. Okay, because the perimeter is is 12 plus 12 plus 12 plus 12. So 4 times 12 is 48 centimeters. Okay, lateral, not lateral, the slant height, lowercase l, is 8. They already give that to us. So capital L, okay, lateral surface area is 1/2 times 48 times 8. So plug that into your calculator or whatever you're using to use your calculations. 192 centimeters squared would be the lateral surface area. Now we need to find the total surface area, the big S, okay? And big S is equal to capital L, big L, plus capital B, big B. We already know L. We figured it out right here. It's 192. Big B, in this case, is the area of the square base. Side is 12 centimeters, so big B is equal to 12 squared, S squared, which you all should have memorized, is 144. Now, we're just going to add, to find big S, we're going to add 144 plus 192, and that gives us 336. And what units? Centimeters squared. Okay, can you just respond to Dad's text and say yes? All right. Number 2, I'm not going to work through that one. I'm going to let you work through that. But when you get the answer, okay, you should get. You know what? Now that I'm looking at that, you need to find out lowercase l. So maybe I will work through that one with you. Okay. Thank you. So we have a square pyramid with base lowercase s is equal to 18 centimeters. Sorry, I'm communicating with Marcus while I'm doing this. Okay. So square pyramid with a base s is equal to 18 centimeters, and a big H is equal to 16 centimeters. Okay. Now, in order to figure out the lateral surface area of this, I have to know the slant height. I'm not given the slant height in this case. So how am I going to figure out the slant height? Think about the rectangle that we drew above. All right, I'm just going to use that idea right down here of this rectangle. And we have side is 18 centimeters. Remember, this bottom portion of that right triangle that we can draw is half of that. So this length is going to be 9. This is the height. The big H of the right triangle is 16. And what we don't know is the slant height. Okay? So using the Pythagorean theorem, and I'm sorry, I should have swiped to a blank page so that we could write this easier. But using the Pythagorean theorem, we're going to have L squared is equal to 16 squared plus 9 squared. Okay, so you're going to plug that in. So L squared is equal to 337. We're going to take the square root of 337. and that is approximately, we're just going to round, that's approximately 18.4. Okay, now I have my lowercase l. Now that I have lowercase l, I can solve this entire problem because big L is equal to the perimeter times the slant height. Okay, so again, this is L is equal to 18.4. So big L, lateral surface area, is going to be 1/2 times the perimeter. Okay, the perimeter is going to be 4 times 18 because there's 4 sides and they're each 18 centimeters long, times the slant height that we just calculated, 18.4. So 4 times 18 is 72 times 18.4 divided by 2 is 662.4 centimeters squared. All right. Now to figure out our big S, big L plus big B. So 662.4 plus the area of our base. We have a square, side 18, so 662.4 plus 18 squared. I'm just plugging into my calculator. And that is 986 4/10 centimeters squared. Okay, so that's number 2. Go ahead, work through number 3 on your own, and you should get L is equal to 11 7/10 feet squared, and total surface area is equal to 15 6/10 feet squared. Now, a circular cone is similar to a pyramid, but has a circular base. The curved surface is called the lateral surface. The lateral surface has been sliced into 4 congruent pie-shaped pieces and arranged as the triangles were arranged previously for the pyramid. That's right here. As the lateral surface is cut into smaller slices, the base and the height of the parallelogram-like area become closer to the circumference of the base and the slant height of the cone. As with the pyramid, we can insert 4 more pie-shaped pieces forming a parallelogram-like figure. That's right here. Again, we only want half of the area of this parallelogram because we want this right here. This is the net of that. So the formula for the lateral surface area of a cone is similar to the formula for pyramids, with circumference replacing perimeter. So lateral surface area is equal to 1/2 times the circumference times the slant height, okay? And substitute for the circumference. Circumference is pi r, circumference is 2 pi r. So when you multiply 2 pi r times 1/2, that 1/2 and that 2 are just going to become 1. So you're just going to end up with pi r L. All right, so that gives us the formula for the lateral surface area of a circular cone. L is equal to 1/2, big L, is equal to 1/2 times the circumference times little l, which simplifies to big L is equal to pi r little l. Then the surface area of a circular cone, surface area is always lateral surface area plus the area of the base. So the area of the base, because we're talking about a circular cone, that base is always going to be a circle. So big B is pi r squared. Big L, as above, is pi r L. So example number 3, find the surface area of the cone. All right, so we have a slant height of this cone of 10, and we have a radius of this cone of 3. So big L is going to be pi radius L. Plug in what we know. Pi times the radius of 3 times the slant height of 10 is equal to 30 pi. And I'm just going to leave this in units of pi until I'm all the way done. Then big S is going to be equal to big L plus big B. So I need to figure out what big B is. Big B is the area of the base, which is a circle. So big B is equal to pi r squared. So in this case, it's equal to pi times 3 squared. So it is equal to 9 pi. So big S, L plus B, big L plus big B is 30 pi plus 9 pi. is equal to 39 pi. Now substitute 3.14 for pi, and when you multiply that, you get approximately 122 and 5/10. And we don't have units, so units squared as our answer when we round to the tenths. Skill check number 2, find the surface area of the following cones to the nearest whole number is what it's asking us to do, all right? Number 1, do it on your own for practice, 75 meters squared. Number 2, do that on your own for practice, 143 inches squared. And number 3, let's knock that guy out together. Diameter is 10 feet, lateral surface area is 8 feet. Big L is equal to pi, little r, little l, okay? So that is equal to pi. Little r is not 10. Little r is half of 10. That's why I wanted to do this one. So pi times 5 times 8 gives us 40 pi. Then, what is big B? Area of the circle, okay? Pi r squared is equal to pi times 5 squared, so 25 pi. Big S is equal to 40 pi plus 25 pi gives me 65 pi. So 65 times 3.14. Gonna plug that in. 65 times 3.14 gives me 204 and 1/10, but we were asked to round to the nearest whole number, so that is approximately 204 feet. There's the answer. Last part of this lesson, a sphere. What is a sphere? A sphere is a three-dimensional closed surface, every point of which is equidistant from a given point called the center. Equidistant means exactly what you think it means. It's an equal distance from the center. Think of a basketball, all right? A diameter is a chord that is super distracting, is a chord passing through the center. The chord AD is a diameter of sphere O. A radius is a segment that connects the center with any point on the sphere. OB is a radius. So here is OB right here. Here's AD. Any plane passing through a sphere intersects it in a circle. The farther the plane is from the center, the smaller the circle. The largest circle occurs when a plane passes through the center of the sphere. This circle is called the great circle. The great circle and the sphere have the same radius. If two perpendicular planes pass through the center of a sphere, they divide the sphere into 4 equal sections called lunes. Visualize quartering an orange, okay? So cutting an orange into 4 equal portions by slicing it once vertically and once horizontally. The figure shows such a quartering. That's here. It can be proved that the area of a great circle is equal to the surface area of one of the lunes, though the proof is beyond the scope of this book, so we are not going to prove that. You're just going to have to trust this. The area of a great circle is just the familiar A is equal to pi r squared. Thus, the surface area of a sphere is 4 times pi r squared because there are 4 equal sections called lunes. Each one has an area of pi r squared, so 4 pi r squared. Formula for the surface area of a sphere, S, big S, is equal to 4 pi r. Okay, and that should, done. I just got my cord stuck onto my book. All right, I just noticed an issue in our book. Where is the issue? Right here. That should have a 2, okay? If your book does not have that there, please feel free to go ahead and write that in. It should be 4 pi r squared. Now, find the surface area of a sphere in example number 4. All we have to do, big S is equal to 4 pi r squared. So big S is equal to 4 pi. The radius of the sphere is 8. 8 squared So 64 times 8, and we're using 3.14, is equal to 1,607 and 68 hundredths. And I'm trying to figure out why I got a different answer than my book did. 64 times 4 times 3.14. I don't know what I did the first time. Now I have the right answer. Okay, 803.84. So we're going to round that to tenths. 803 and 8 tenths feet squared. All right. I'm only going to do example or number 3 and skill check number 3. You practice with the other two. 50 centimeters squared for number 1. For number 2, 211 meters squared. And for number 3, big S is equal to 4 pi r squared, equal to 4 times 3.14 times the radius. The diameter is 10 feet, so the radius is 5. 5 squared, so 25 times 3.14 times 4 gives me 314 feet squared as our final answer.